Okay, now we're ready. So, if you remember clear back to algebra, we had an equation of a line and slope-intercept form. Y equals mx plus b. So you plug the slope in, you plug the intercept in, you end up with an equation of a line. Same thing with a circle. We have an equation of a circle. The equation of a circle looks like x minus h quantity squared plus y minus k quantity squared equals r squared. Now the x and the y are just part of the equation. The h and the k, those come from the center. So the h and the k is the ordered pair for the center. And the r kind of makes sense for this one. What do you think the r stands for? And if we're doing a circle, it's the radius. So the r is the radius. So that's the equation of a circle. That's what it's going to look like. Same as the equation of a line in slope-intercept form is y equals mx plus b. You plug in the slope, you plug in the intercept. On this one, you've got this formula. You plug in the center into the h and k. You square the radius, it goes to the end. Now, the big thing you need to kind of remember on this, if you notice, inside here we have minuses, and your ordered pair is positive. So therefore, whatever the ordered pair is, when it goes into the equation, you're going to do the opposite sign. That's the biggest thing you're going to need to remember, or maybe the trickiest thing you're going to need to remember. So make sure you've gotten the formula written down, and then we're going to go ahead and take a look at some examples. You may need more time on the formula? First two are real easy because you're just plugging things in. So 1 and 2, you're plugging your information into the formula. And like I said, the formula is going to look like this. That's kind of the look of the formula. The center, remember I said was the h and the k. But when it goes down here, don't forget to change the sign because the formula says minus, so it's the opposite of whatever this is. So if this is minus 3, down here I put plus 3. If this is minus 11, down here I put plus 11. The radius is 6, so radius squared is 6 times 6, which is 36. So there's your equation for the circle. There's your equation. Now go and try number 2. Kind of plug everything into your equation. Give it a shot.
Y minus 15. Oh wait, never mind.
So here's kind of the look. So the first parenthesis, what's going to be in the first parenthesis?
X plus 16.
Don't forget to change your sign. So x minus 16. So x minus 16. Because remember, the formula is x minus the h, so that changes the sign. The second parenthesis is going to be what?
Y plus 15.
Y plus 15. So this is minus, I put plus. And at the tail end, I have radius squared. And in this case, it's going to give me 9. Because 3 squared is 9. So like I said, these first two, I'm just taking the information and plugging it where it belongs. I'm just plugging it in. Not really doing much of anything with it. 1 and 2, are we okay? Now 3 and 4, I'm giving you a graph. So from these graphs, we're going to find the center, find the radius, and then write the equation. So let's take a look at 3 and 4. So I've got my circle here. Here's my circle. Where does it look like the center of the circle is?
1. Or would it be 2?
Wouldn't be 2. On number 3.
Oh, at number 3.
I'm looking at number 3. So where's the center of number 3?
It looks like about -1.
Looks like about -1. So here's my center. I'm going to go ahead and mark it. Now, when I'm talking about the center, I need an ordered pair. I need a coordinate. So if I were going to write the coordinate for that red dot, what's the coordinate for the dot?
The origin.
Well, it's not quite the origin, because the origin is smack dab here. So this is the origin, 0, 0. This is going to be what? What's the ordered pair? What's the coordinate? 0, -1. And be real careful that you get them going the right way. I've seen a lot of people, when I was glancing through papers, that kind of switch those two numbers. So it's here. It didn't have to go sideways. It only went down 1. So 0, -1. 0, -1. Now from there, I can figure out what the radius is just by counting blocks. And it's easiest to kind of go on the grid. And it doesn't really matter which direction you go. So from the center to on the circle, how many blocks is it? What's my radius? 4. 1, 2, 3, 4. And like I said, it doesn't matter which direction you go, it's going to be 4. So my radius is 4. So now I have a center and I have a radius, and I can plug it all into an equation. Now this is just plain old 0. I mean, I could put x plus 0 squared, but I don't really need the 0. So I'm just going to leave it as x squared. And then plus in parentheses y. If that's a minus, down here I put plus 1. Quantity squared equals, if this is 4, what's going to go at the tail end? 16, because it's radius squared. So try number 4. Find the center, find the radius, plug it into a formula. Find the center, find the radius, plug it in. So it looks like the center of this circle is going to be right here. So what's the location of the center? What's the ordered pair? -1, 4. So from my 0, 0, -1, 1, 2, 3, 4. So -1, 4. My radius is going to be what? Be careful.
1.
1. Because kind of the light line is a halfway through. Because it went 3, light line 4. So to the next dark line is just 1. So 1. So some of these guys could put extra lines in for kind of the halfway mark. Some of them they don't. So just be real careful when you're looking for the lines. So now I can plug it in. X, if that's a minus, I put plus 1 squared. Plus y, if that's a plus, I put a minus. Squared equals 1 squared, 1 times 1 is 1. So I get a 1 there. So 3 and 4. we're going from a graph. From the graph, I can figure out the center, I can figure out the radius, I can write an equation. Are we okay on number 3 and 4? Let's see, a couple people write. We need more time on this. Now, 5 and 6, we're going the other way. 5 and 6, I give you the equation. We're going to have to figure out the center, figure out the radius, and then graph it. So we're going the other way. So number 5 here. Center. So from my equation, remember the center comes from these, but don't forget to change your signs. So what's going to be the center of this circle? 1, negative 1. So 1, negative 1. That's my center. The last number is 25, which is the radius squared. So if radius squared is 25, radius is going to be what? 5. Because I can take the square root of 25 and get the radius. So now I can go ahead and put this in my graph. So I'm going to graph 1, negative 1. Now again, be careful, sideways, up and down. So I'm going to go 1 to the right, 1 down. So there's my point. Now my radius is 5, and I want a few different points I can draw this around. So I'm going to go 5 in 4 different directions. So I'm going to go 5 up, 5 to the right, 5 down, 5 to the left. Now I want to draw my circle around that. Now I'm not looking for a perfect circle, but just make sure you get some rounded edges. Don't just connect, because if you connect, it's going to look like a diamond. Make sure it's rounded. And I know it's kind of hard to sometimes draw the circle, but just make sure it kind of looks round, not like a diamond or a square. Make sure it has some rounded edges. And it seems like the bigger the circle it is, the harder it is to draw. So just do the best you can. Just make sure it looks rounded. So 6, you're going to do the same thing. Figure out the center, figure out the radius, and then graph it. So take a moment, try number 6.
Will the radius just be 1?
Yes. So where's the center of this circle from the equation? What's my center ordered pair?
1, negative 4.
1, negative 4. Because remember, it comes from these, positive 1, negative 4. The last number is 1. My radius is going to be still 1, because the square root of 1 is just 1. So I'm going to end up with a tiny little circle. They gave us a pretty big graph for a tiny little circle. So 1, negative 4. There's my center. I'm going to go 1 out in every direction. This one's pretty easy to draw because it's tiny. So there's my 4 points. Draw your circle. So on those two, I gave you the equation. From the equation, I could find the center and the radius, and then I could graph it. Are we okay on this? Now, the next two are probably the tricky ones. So on these two, I just want you to kind of pay attention for a little bit, because I'm going to go to a different graph here for a moment, just so you can see what's happening. Then we're going to go back to this paper so I can kind of explain it to you. I have my graph paper up. Let me make it bigger. me a second, just make it a little bit bigger. Okay, so there's my graph. Now, on this, I gave you a center. So the center, was at 6.4. Now, like I said, just pay attention for a little bit. Then we'll go back to the paper and I'll kind of explain it from the paper. So if I were to graph this, my center is 6.4. So 6, 4. There's my center. Then it says I have a point on the circle at 3, 5. So 3, 5, my center's going to go through that. So my circle's going to be kind of in through here. But it's kind of hard to get a radius out of that because from the center to that point is going diagonally through the graph. So somehow I've got to figure out how big that is for a radius. Now, does anybody have any thoughts on how I can figure out how big that line is?
Oh, can you find the coordinates?
Say again?
Can you find the coordinates for each like circle?
Yeah, I don't want to combine the coordinates.
No, like find the coordinates.
I mean, they gave me the coordinates. My coordinates were 6, 4. And my coordinates were 3, 5. So those are those two coordinates.
So can I go like x? What'd you do? X plus 3 squared plus y plus 6 squared.
No, I'm not sure if you're quite on the right track. But I can kind of create something that looks like a right triangle. So if I have a diagonal line that goes through a graph, I can kind of square it off into one side, and now it looks like a right triangle. So that means this side of the right triangle is 1, which came from 5 to 4, there's 1 apart. This side of the right triangle would be 1, 2, 3, which came from the 3 and the 6. So the difference between the 3 and the 6 is 3. So it's almost like we're finding slope, but we're using that slope to get the two sides of the triangle. Well, now that I know the two sides of the triangle, what can I use to find the third? And yes, like I said, it never goes away. It just keeps coming back. What can we use? How can I find the third side of a right triangle? Oh, come on. We've done this 50 times. Right. I can use a squared plus b squared equals c squared. A squared plus b squared. And in this case, the c squared is going to be the radius. So it's radius squared. So I can plug my numbers in. 3 squared plus 1 squared equals radius squared. 9 plus 1 is 10. So 10 equals radius squared. Now, yes, I put it on a graph. But now we need to kind of take a look at what we can do if I didn't give you a graph to draw it on. So like I said, from the two coordinates, between the 3 and the 6, there's a 3 difference. That's going to tell me what did the x change. Between the 5 and the 4, there's 1. That's going to tell me what the y changed. I can stick it into Pythagorean theorem to figure out the radius. Now, technically, the radius would be the square root of 10. But if I'm putting it into the equation, I'm just going to use this number. Because remember, the equation uses radius squared. So let's see what this actually looks like now. So let's go back to the paper. So I like writing these on top of each other. It's just easier to kind of keep track of what's what. So I'm just going to rewrite these two coordinates and just line them up. So like I said, between 3 and 6, there's 3 difference. And it doesn't matter if it's plus or minus because it's distance. And distance doesn't care. It's like an absolute value type thing. It doesn't matter what direction you're going. Between 4 and 5, there's a 1 difference. Change it into Pythagorean theorem with an r squared at the end. Well, like I said before, 3 squared plus 1 squared is 10, so 10 equals r squared. So now I can go to my formula, x, this is 6. Make sure you're doing it from the center. Don't pull it from this number. It's the center. So x minus 6, quantity squared, plus y minus 4, quantity squared, equals 10. There's my equation. So like I said, those are kind of the tricky ones. They're a bit hard. There's more work to them. So let's look at number 8. Now again, I'm going to write these on top of each other just because it makes it a little easier to keep track of what's what. So my x's are negative 13 and negative 10. So how far apart is negative 13 and negative 10? 3. So they're 3 apart. So if I'm negative 10, negative 11, negative 12, negative 13. So that's 3. How far apart is negative 8 and negative 9? 1. Change it into Pythagorean theorem. Now, I didn't purposely make it the same number, but it is the same number. The 2 you have to do is not the same number. So I end up getting my r squared as being 10 again. So now, take your center, x plus 13, quantity squared, plus y plus 8, quantity squared, equals 10. Equals 10. Now, 9 through 16 goes back through it again. Go ahead and work on it. If you get done, I'll take it.